We're now going to graph equations, and in order to graph equations we need to have 2 points, and or if not, a point and the slope. Since the equation here is in the slope-intercept form, so we're going to use the information such as the slope of the line and the y-intercept. Alright, so starting with the y-intercept, okay, remember in the slope-intercept form, which is y equals mx plus b, the constant here is the y-intercept, or the b. And so in this case, the y-intercept is 6, so the coordinates of the y-intercept would be 0, 6. Then we have the slope. Slope is the coefficient of x, in this case is negative 5/2. Now, how do we use the slope in finding points on the line? You have to remember that the slope is rise over run. Rise is the vertical distance, the run is the horizontal distance. And of course, you have to find out what the direction is. If the rise is negative, that means it's going down. Or if the run is negative, then that's going to the left. Okay, so in this case, because our rise is, the slope is -5/2, then the rise is -5 and the run is +2. So how do we plot the points? In order to form the line, we only need 2 points. However, to be accurate, we are going to locate 3 points if we can. Let's start with the y-intercept. The y-intercept is 0, 6. So locate on the graph. This is our origin. And then you have 0, 6. So from the origin, you go 6 units up. So that's 1. Because as we can see, this is 0, this is 5. So therefore, the increments here are by 1 unit. So that's going to be 1, 2, 3, 4, 5. And so this is 6. So that is our y-intercept with coordinates 0, 6. Alright. So now, from the y-intercept, we are going to, so we're now going to find another point using the slope. So from the y-intercept, because the rise is -5, so which means from this point, we are going to move 5 units down. So we have here, this is 1, 1, 2, 3, 4, 5. Okay, so that's 5 units down, and then our run is 2, so we go to the right. So from the y-axis, you move 1 step to the right. Again, as we can see, this is 0, this is 5. So our calibration here is the increments are by 1 unit. So this is where we at, right? So we count 2 units to the right, so that's 1. Then we have 2. So the second point is right here. And the coordinates of this point are, that is, this is 2, that's 1, so that's going to be 2, 1. Alright, so since we have the 2 points, then we can connect the 2 points with our line and draw our straight line. So when we draw the line, we don't just limit our line to connecting the 2 points. We have to extend it all the way up and down. Okay, and so because the line is composed of points where the coordinates are solutions to the equation, then we can use the line to determine other solutions of the equation. So obviously, one of the solutions of the equation is the y-intercept. So if we will check the y-intercept, there is 0, 6. And if we substitute with 0, 6, the equation is y equals negative 5 halves x plus 6. Substitute 6 in, okay. So y is going to be 6 and x is going to be 0, and see if the equation will be true. So instead of y, we substitute 6. Will that be equal to negative 5 halves times x is 0 plus 6? Well, definitely this product here, negative 5 of 0 is 0, and then plus 6 is going to be 6. So both sides of the equation have a value of 6. Alright, so 0, 6 is a solution. Another solution is this 2, 1. This point is on the line. So let's verify if 2, 1 is a solution. So in this case, our x is 2 and our y is 1. Alright, so the equation is y equals negative 5 halves x plus 6. So y here is 1. And is that equal to negative 5 halves times x, which is 2, then plus 6. Alright, simplifying, we have 5 halves times 2, well, the 2 and the 2 there will cancel. So we simply have, okay, negative 5 plus 6, and negative 5 plus 6 is equal to 1, which is also the value on the left side of the equation. So therefore, the ordered pair 2, 1 is also a solution to the equation. Alright, another solution that we can, so therefore, okay, so using the line we can, so the points on the line are, the coordinates of the points on the line are solutions to the equation. So points that are not on the line, their coordinates will not make this equation true. So therefore, their coordinates are not solutions to the equation. For example, this origin here, this origin is not on the line, so the coordinates, this 0, 0 is not a solution to the equation. Alright, let's find another point that is exactly on the line. Okay, maybe this point here. Okay, and the coordinates are, so I see this is 4, so x is 4, and over here y is also 4, so 4, 4. So let's find out if the coordinates 4, 4, ordered pair 4, 4 is a solution to the equation. So our x is 4 and our y is also 4. So substituting these numbers into the equation, you have y equals negative 5 halves x plus 6. So y is 4. Will that be equal to negative 5 halves times x, which is also 4, plus 6? Okay, so we have 4. 5 halves, we can cancel the 2 and the 4 because they have a common factor, which is 2. So that means we can, so 4 divided by 2 is 2. And then 2 divided by 2 is 1. So now we have negative 5 times 2 is negative 10 plus 6. So negative 10 plus 6 is 4, which is also the value on the left side of the equation. So this ordered pair 4, 4 is a solution to the equation.